Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we're going to be going over section 4.1, Introduction to Graphing. Now a lot of the time you will see things on the news, on the internet, on different places that have information that are set up in a two-dimensional graph to kind of give a visual representation of the events that are occurring. So what we're going to do is we're going to go over what every piece of a graph means, what it means to be continuous or discrete, what it means to be increasing, decreasing, or constant, what it means to be jerky or anything else like that. So let's go over some of the different types of things. In graphing, there are two main pieces. There is the dependent variable and the independent variable. The dependent variable is a variable whose value depends on another variable. So, for an example, the price of gas. Gasoline prices are determined by the price of oil. If oil goes up, gas prices go up. If oil price goes down, well, gas prices go down. So, dependent variables would be things like the gas price. The independent variable would be a variable whose value doesn't depend on anything else. So a variable whose value does not depend on any other value. So this is the one that just doesn't care. This is the one that sets itself. For an example, a lot of times you think of a person who doesn't care about another person, but they're still in a relationship and for some reason, and after a while, pretty soon, because they don't really care about anything else, if they don't care if their friend wants to go to the movies, they want to go watch whatever they want to do, they don't care what the other person wants to wear, they're going to wear what they want to, that sort of thing. Well, pretty soon they quickly become an X, mainly because if you don't care about your partner and you do everything yourself and expect your partner to go around and work around you and do everything that you want to do, pretty soon they're going to dump you. So those are what are called X's, or independent variables. The dependent variable is often called the Y, because whenever you see somebody that is still with their ex, you will wonder why, and the reason why is because they are dependent upon that person for one reason or another. So when we're graphing, the independent variable goes along the horizontal axis called the x-axis. So for an example, we would have this horizontal axis here, and we'd call this the x-axis, which is the independent variable, the one that doesn't care about anybody else. And then you have the y-axis, which is the vertical axis, and that one has a value that depends on what the x value is. So one of the ways that I remember this is that you always want your x's to be horizontal, preferably with 6 feet of dirt on top of them. And your y, well, if you know y, you always ascend. And so the y goes up and down because you are ascending because you know y. And the x is horizontal, preferably with 6 feet of dirt on top of them. So we have our independent variable, our dependent variable, our x-axis, and our y-axis. And now the graph itself can do a lot of interesting things. For an example, the graph could just remain steady and not change. This section, we would say that this was steady. that it would be unchanging. That the graph is horizontal. And lastly, that the graph is constant. That is the real key word here. If a graph is constant, that means it doesn't change. That means it's going to be flatlining. And then sometimes the graph goes down. And sometimes it goes down at a steady rate. And that doesn't look very steady to me. And sometimes it goes down at a steady rate. So from there to there, we would say that this would be decreasing because its value is going down. This would mean that it would be dropping. Its value would be dropping. Or that we would have a negative slope. All of these are different ways of saying the same thing. Now, let's say for a moment it was dropping for a while, and then it hits rock bottom, and then it starts to go back up. When it starts to go up, we would call this increasing, which would mean ascending or going up. Or we would say that this is a positive slope. So we have steady or constant, decreasing or negative slope, and increasing or positive slope. But things aren't always this simple. A lot of times we have weird shapes going on with our graphs. And let's take a look at some of them. Let's say that we have a graph of torque compared to RPMs. So here we go. So down here we have the RPM, and up here we have the torque. Now, torque is dependent on RPM. If your RPM is low, your torque is low. If your RPM is high, your torque usually goes higher, but then after a certain point, it actually starts to diminish. So say for a moment we have a car, and we turn the car on, and its RPMs are around like around 1,000. And then as we accelerate, our RPMs go up. But so too does the torque that we apply. But then after a certain level, our RPM kind of drops, or our torque drops, because we change gear, and then goes back up again. And it does that every time we have a gear change. And then once we reach the max gear setting, we start to level off and actually plummet once we get to the very highest levels of our RPM, because at that point the engine's about ready to explode and our actual torque kind of diminishes. So on this one, we can say that from point A to point B, we are increasing, and increasing pretty steadily. But from B to C here, notice how we have this sharp drop. So from A to B, we are increasing steadily. And then from B to C, we have a sharp drop. But then from C to D, we are again increasing steadily. And then from D to E, we have a sharp drop. And so forth and so on, until we reach this last portion, which is F. And then at F, we have a semi-sharp drop. So each one of these represents a change in our torque compared to our RPM. As we go from A to B, we have a steady increase in RPM and in torque. Then we do a gear shift, and when that happens, we have a sudden drop in torque for a little bit, and then it goes back up, etc., etc. So this is a neat way to show how torque varies with your RPM. Now, there are two different types of things. If you'll note that this is kind of a continuous line. This, because it's a continuous line, or a non-broken line, this is what is called a continuous graph. Continuous graphs are graphs where there are no breaks in the line. A good way to think of this is continuous means that you don't lift your pencil up. If you can draw the whole graph without ever lifting your pencil, then it would be a continuous graph. But then there's a different type of graph. There's a graph called a scatter plot. And this is often what scientists use to look for trends in data. So let's say for a moment that we're looking at average temperature over the last 500 years. So when we're looking at our average temperature, so we would have time in years as our independent variable, and then our temperature as our dependent variable. And over time, it started out, it kind of fluctuated a little bit. But then when we hit the Industrial Revolution, it started being a little chaotic, but started going up, and the average temperature was increasing. Now you'll note that even though there are a lot of dots, there aren't any lines connecting them all. So this is what is called a discrete graph. A discrete graph is a graph where the data is in points and not a line. In other words, if you have to lift your pencil, more than likely you're going to have a discrete graph. So this little discrete graph, even though it looks like you could draw a line that kind of fits the data, isn't a continuous graph, but it's discrete because every single data point is a little dot. And believe it or not, that's about it for our introduction to graphs. Let's quickly go over everything that we've learned. We have learned about the independent variable, the dependent variable, the x-axis, the y-axis, and note that the x-axis is associated with the independent variable and the y-axis is associated with the dependent variable. We have learned about continuous graph versus discrete, where continuous is a nice pretty line, where a discrete graph would be a lot of points. And we have learned positive slope, which is increasing, negative slope, which is decreasing, and we have constant slope, which is flatline. And that's it. That's really it. It's all about concepts today. All right, let's go ahead and go to our favorite part, the homework. So let's watch our homework. Our homework is going to be section 4.1, which is on page 237 of our textbook. And because it is really easy, yep, that's right, you're going to get a whole bunch of them. We're going to go numbers 1 through 21 odd. All right, that's it. Go ahead and grab your textbooks. Good luck and have fun.